A very good day to IR Nick, Matt, and my fellow friends. My name is Vigan, unlike Stephen to say, metric number AA20200. I have took this course Research Methodology and Pre-Project under the supervision of Dr. Yuvandar. Today I'm going to present about my project, which is classification and identification of type of peat using color code of NICS Pro color sensor. Now let's get to the introduction. Peat. What is peat? Peat is the top layer of organic matter in a soil that is largely made up of partially decomposed plant matter that has accumulated due to waterlogging, oxygen shortage, excessive acidity, and nutrient deficit. The importance of classification and identification of peat soil not given in the field of engineering, where new peat discovery gives new findings in the field and also for development of a place. Thus, we have approach to classify and identify peat soil using NIC-Pro color sensor using color code. As you can see in the map given at the slide, most peat are found at the east coast of Peninsular Malaysia and also at the west coast. And there's a peat found in Sabah and also at Sarawak. There's a major at the coastal area. My project is mainly based on the color code of the soil. So white color. Color may be a helpful signal of some soil characteristic in general as well as some chemical activities going on below the surface. For example, when the soil is in dark color, it means that it has high content in organic matter. So soil classification was done by using Munsell color chart as a standardized color code to identify the soil, which is the conventional method still using today. NIC Pro sensor device can help to change the method that was being implemented before to create accurate and precise data to find the color code of the soil. The picture that is shown in the slide is NICS Pro 2 and NICS Mini 2 color sensor. For every invention, there's always a problem to start it up. So for this project, the problem statements are the Munsell color chart must be used under ideal conditions only, such as sunny, clear lighting, and a wet environment. The other problems are the human aspect of soil color determination is limited by poor vision and reading may vary from person to person. So it depends on the person who uses the Munsell color chart book. So faded colors that does not have the same color code as the soil will affect the readings and the data. So the picture below shows the faded color chart that cannot be used, and also as the other picture, the person will based on their perspective is affected on the Munsell color chart readings. Now that I have identified the problem, let's state the overall aim for this project. My aim is to standardize NICS Pro color sensor for identification of peat soil color code. And my specific aims for the overall aims are standardize a method by using NICS Pro color sensor for peat soil classification, compare the result with Munsell color chart to check the accuracy of the chart compared with NICS Pro color sensor readings. The scope of work for this project are conducting laboratory tests for peat soil containing 75% above organic content. The tests are moisture content, organic content, static shear box test, liquid limit, fiber content, pH test, and finally Macintosh probe test. And I'll also be using the NICS Pro color sensor and use a standardized method to get the results. And also, I will capture and analyze the soil color code using Munsell color chart, which is the conventional method. And finally, I need to confirm that the soil that I've get is peat soil. Now let's get a little bit detail into the background study of what is NICS Pro color sensor and also Munsell color chart. Okay, NICS Pro is widely used in the color industries such as textiles, paint industries, and so on. So NICS Pro color sensor is a suitable device to capture color in which where it creates its own environment, blocking out the sunlight and emits LED light to get the accurate color coordination. Whereas the Munsell color chart, which is developed by Professor Albert A. Munsell over a century ago, was accepted by the United States Department of Agriculture (USD) for use in soil research. The fundamental base of hue, value, and chroma, which is the purity of color, on a three-dimensional scale, is imprinted in a color chart book. These are the NICS Pro color sensor and Munsell color chart book. The NICS Pro color sensor mechanism is detailedly imprinted, as you can see in the slide. Now that we have known the color code of the soil, we need to make sure whether it is peat soil or not. So we need to classify it. There are several methods that we can use to classify peat soil, which includes ASTM and 1/4 scale. ASTM stands for American Society for Testing and Materials. Table 1, which is the ASTM, shows the fiber content, ash content, acidity, and moisture content, which we can calculate based on the peat soil that we have gathered. And for table 2, which shows the 1/4 scale table, which determines the based on appearance of peat water that is excluded when the soil is squeezed using hand. Now, as you can see in the slide, it is 1/4 scale table. So, for example, we have gathered peat and now we are using it, and we have gathered the data which shows that completely decomposed peat with no decimal plant structure, and when squeezed, all the wet peat escapes between the fingers. So we can conclude that it has very high moisture content, so it falls under the category of H10 and B5. Now let's look at the methodology. Okay, first of all, I've constructed this diagram to make the project get the best result and accurate as precise as possible. Okay, sampling. I'll be using the Macintosh probe test to gather the sample and also indicate the pH level, which should be below than 4.5 pH level, and also conduct one post scale testing at the site area. And Munster color chart and NIX Pro color sensor is also conducted at the site at the same time to get the color code of the soil. Later on, the samples are then bring to the lab to conduct laboratory experiments, which are moisture content, organic content, direct shear box test, liquid limit, fiber content, and also pH test. And finally, after gathering all the results, then we will analyze the uh, results and also have a discussion whether the result that we have obtained has solved our problem. And the conclusion and recommendation will later on will be indicated based on the result that we have gathered. For literature review, I've gathered four main research that I've conducted before in other universities. Why these researchers? Because they have used NIX Pro Color Sensor as their main equipment to gather results and more precise and accurately. So I have gathered this to put as my references for my project. This is the Gantt that I'm using for the project. And first of all, topic finding, which is my topic, classifying peat soil using NIX Pro color sensor. Later on, journal and paper, which I use my references for my literature review, and methodology, which I show you in diagram. Slide preparation, which is this, and also chapter 1, 2, 3, which is my thesis final draft for this semester. And later on October, November, December, January, I'll be doing the soil sampling, soil sample testing, analyze data and discussion, prepare report, slide presentation and presentation, review, and submission, which is my coming semester. Now let's look at the research questions and answer that you might need to know. So first, how you design research objectives. So based on my aim, which is standardize a method using X color sensor to create a new way of classification, identification of color soil. The next question is, for each objective, which are the strategies to manage the sample? So the first objective, which is standardize a method using X color sensor. I strategize creating an improved and simple way for the understanding of people so that they can perform and get results accurately than the conventional way at in situ, which at site. And the second objective is comparing the result of NIX Pro color sensor with Munsell color chart. How do I do that? After culturing the sample, NIX Pro color sensor and Munsell color chart are used to determine the classification identification of soil. The result will be then interpreted in the form of hue, value, and chroma, and based on that I will know which whether mixed pro color sensor or Munsell color chart are accurate. Now for the final question, which is how the research problem can guide the results, analysis and findings. So first of all, for the problem statement that I've mentioned before, which is using the Munsell color book, the conventional method is not so effective to determine the color code of the soil. So I've now created an overall aim to solve that problem. So the aim then the aim has been separated to two main specific objectives, which are created a method or standardize a method by using NIX Pro color sensor and also comparing the Munsell and NIX Pro color sensor's result. Okay. Later on, I will gather the result, and after that I will do an analysis based on the result that I've gathered, and I will be also using references from the literature review that I've shown before slides. And also I will see whether the problem that that is before, has been solved using the results that I've gathered. Later on, I will conclude that whether Nix Pro is more effective or not. Now let's look at the expected outcome that we want for this project. So the Nix Pro color sensor might able to change the perspective of identifying and classifying the soil according to its color code. So we might change the method from conventional, which we was using Mansell color chart book, rather than can use now Nix Pro color sensor as a standardized method. Then after that, the results of the color code might be more accurate and consistent uh, compared to Mansell color chart. Finally, these are the references that I use for this project and also for this presentation slide. And that's all from me. Thank you.